thought about the exam, and I get some ideas to discuss with you in the real analysis. That will sometimes this ask the questions in real analysis, and that is some easy questions, so we can easily uh, solve them. Okay. So in the last lecture, we had discussed about the functions of several variables. Okay. So here the audience, anyone which was in the last class. Vasu, you was in the last class, I think. Okay, so in the last class we have to one question in the frequently they ask in the examination, that is about the directional derivative. Okay, so let's
Yes, sir.
yes. Okay, so let's write the formula to find the directional derivative. Then we will perform some examples. Okay, so if we have a function, this is f from Rn to R. Okay, it means n variable function. And we need the directional derivative in the direction of u. In direction u vector or u. So it means this u have some points from Rn. So it means like this. It is u1, u2, u3, and so on up to un. Okay, and let us at the point that is your C, and the denoted C, and the C will be also C1, C2, and up to Cn type n tuple. Okay, so how we defined uh, such directional derivative is by this formula, that is du fc is just equal to is limit h tending to 0 f of c plus h into u minus fc divided by h. Okay, so you know that this is u depending on the number of variables. Okay, so this is u defined like this. So you can also write this in this another form. This is limit h tending to 0, and this is f of this c means c1 comma c2 up to cn, plus this is h times u1 u2 up to un, and minus fc divided by h. Okay, so you can just also write this like this. This is limit h tending to 0, and this is f of c1 plus h times u1, and this is c2 h times u2, and up to this is the point cn plus h times un. Okay, and minus of f. fc means this is point. So you can just write this point here. So you are finding the value of the function at this point, and this divided value. So in this manner, we will calculate the derivative in the direction u at the point C. Okay. So let's do an example, that is the problem from the gate. So I have a problem. Question is here. Okay. Oh, where is the problem? Is this okay? So question is this. So let's perform this question. Okay, question is this. Let this u x y z. It means the function of three variables is this defined like this: x square minus 2y This is problem from the GATE exam, Z square. They ask in the examination for this x, y, z is from three variable function is there. Okay, then directional derivative, then the directional derivative of u in the direction, uh this is your 3 upon 5 ik and minus 4 upon 5 jk, sorry kk, at the point at the point 510 h. What will be the direction derivative? We have to find. Okay, and it exam is from where they asked in the quiz. I think it is a problem from 2000. I think it is. Okay, so let's start solution of it. So here the function fxyz, here is function is given in u. So you can also in your form, if you are not comfortable for that, you can write in this way. This is fxyz is x square minus 2y and plus of 4z square. Okay, this is your uxyz because I will use u here. Okay, so u is here what? U is this is 3 upon 5 ik minus 4 upon 5 kk. So because we are working on the three variable, so you will also written like this. This one, this is 3 upon 5 0, and this is minus 4 upon your u1, this is your u2, and this is your u2. And what is the point is here? This is c point is given, that is your 5 1 0. You can just also say this is your c1 c2 and c3. And we know, so you know that the directional derivative in the direction of u at the point c is defined as, अभी हमने formula देखा था, it was in this way. At the point c is just equal to limit h tending to 0, and this is f of c plus h times u minus fc divided by, okay, so this is what I have less data, so I'm just off my video. Okay, so here we can just put it here like this. This is limit h tending to 0, and this is f and the point c. C is what? This is your 5 1 0. This is point c, and plus h. This is 0.3 upon 5 0 minus 4. This is your u, in which direction we want, and this is the value of the 5 1 and 0, value of the function. So from here we will just simply calculate. This is limit h tending to 0, and here will be the value 5 plus 3 upon 5 h. Okay, this is the value, and this is 1 plus 0, it means 1 it will be, and 0 minus this, so it will be minus 4 upon 5 into h. Okay, minus the f of 5 1 0 and divided by, and simply now you calculate the values. Okay, so you know that function x y z is defined like this. Okay, so I'm just putting the values here. So it will be limit h tending to 0, and f the x is 5 plus 3 upon 5 h whole of square. Okay, and minus 2, and 1 y is 1, so this is 1, and plus of 4, and this is z is minus 4 upon 5 h. It means this is minus 4 upon 5 h whole square. Okay, and then this is in the place point function value and the point 510. So you will have this is 5 square and minus 2 into 1 is here, and z is 0 here, it will be 0. Okay, and divided by. So let us see what will remains. So this is limit h tending to 0. So we have 25 and this is 9 on 25 h square, and when you multiply you will get 6 of h, and this is minus of 2, and you have here this is 16 for 64, 25, and this is h square, and here 25 minus 2 is 23, minus of 20 divided by h. Okay. So next we can just simply, this is limit h tending to 0. So 25 minus 2 minus 23 will have 0. So we will have just take h outside. It remains 9 upon 25 of h plus 6. And this is plus 64 upon 25 of h and divided by h. Okay. So from here, you just have this is h and h cancelled. We will have 0 plus 6 plus 0 means 6. Okay. So understood? Please let me know, participants. You have understood about the directional derivative, how we calculate.
Yes, sir.
Okay. So next about so simply you just learn this formula, and how we apply this formula. You just remember the things, and you are able to do this type of problem easily. This is very, so they ask in the 3 variable, most of the time in the 3 variable function. Okay, so it easily remember this formula. Okay, next I'm just thinking about, they ask about the problems related to countability. Okay, countability of a function. They also ask about the problem. That is a simple problem. So I will discuss about this. So a set, if I'm just taking a set like this is A. This is the A set. So what meaning of the countability? It means that what is the cardinal number of this? Okay, so cardinal number is defined. So I'm going to this, if we have a set, and just in the brief the thing, if we have a set, so that set is of the 3 types. It will be finite. Firstly we can just say it is finite or infinite. Okay, a set is we have a set, and that is finite or infinite. And if a set is infinite, there are 2 types. We say it is denumerable. We say it is a denumerable or uncountable. Okay. So if a set is finite or denumerable, that is this implies countable. Okay, it means mainly we have a set that 2 types, that is countable or uncountable. Okay, if a set is finite or denumerable, that is called countable. Okay, so we know about the finite set. If I have some cardinality, the finite number, we can say that is a finite. Okay, what is the meaning of a denumerable? If a set is infinite, if a set is infinite plus innumerable, what meaning of innumerable? We can able to listing the numbers. Okay, we can able to list the numbers, list the elements, like A1, A2, A3, A4, A5, and so on. If we able to and it is tending to infinity, if there is an infinite set and we can able to enumerate the elements of the set, and that set will called the denumerable set. Okay, yes, sometimes they say countably infinite. Infinite. Okay, so a set is denumerable or finite is called countable. So if uh, so how we just see a set and be able to say it is a denumerable or not. So we know the equivalent set. Equivalent. What are the equivalent set? If two sets are said to be equivalent, if their cardinal number, if a set A is there and here the set B is there, if the cardinal number is equal, then A is said to be equivalent to B. I'm not saying the elements are same or elements are less or equal, or we are also not saying they are equal set. We are saying only the cardinality of the set A is equal to the cardinality of the set B. Okay. And one thing, let us also we can define this equivalency of the two sets like that. We know that if a set have a cardinal number A, which is less or equal to cardinal number of B, we define able to define a one function. Okay, and if we are have a cardinality of A which is greater or equal to cardinality of B, we can able to define a onto function. Okay, if we are combine these two things, we can say this implies if the cardinality of A is equal to cardinality of B, then that should will be exist a one onto function. Okay, so it means that a set is equivalent to B if that the function there exists a function f from A to B, which is bijective. Okay, so now we can also say there if we can say a set X is said to be denumerable if there exists a bijection between X and N, set of natural number. Okay, and we know that the set of natural number is 1, 2, 3, 5. So this is a denumerable set already. So if we able to find a bijection between two sets, then that those set will be have the same cardinality. If n is denumerable, then that set also will be the denumerable set. Okay, and the cardinality of this natural number is defined. This is LF naught, even though any denumerable set. Okay, so this is thing about the denumerable set. Now we have a set of real number. Cardinality of set of real number is defined to be C, and this is the uncountable set. Okay, so any set that is have a bijection between R will be have the cardinality C, and C is the and that C is the R is the uncountable set. It means that set will be the uncountable. Okay, so let's we have a cardinal number. According to that, we can able to say a set is countable or uncountable. So easily we are remember We know that is 1 is less than 2 is less than 3 upward to some n, and is a finite number, and we have LF naught. This is the increasing order of the cardinal number of the sets. Okay, we are writing the list of it. And then we can see, and then after we have this 2 to the power c, and this is 2 to the power c. Okay, how we can say, if I'm just taking a set A with the cardinal number c, and we want the cardinal number of its power set of A. So what will be the cardinal number? This is 2 power c, and this 2 to the power c is not exactly equal to c. It is more than c. So if the cardinal number is more than c or equal to c, so that type of set is said to be uncountable. You just remember these sets uncountable, and up to LF naught, this is countable set. So if you want to say there is a finite set that is countable already, if there is a set which is have listing, we can able to list that elements of that set will be said to be countable set. Otherwise, that infinite set will be said to be uncountable. Okay, so you remember this about the cardinality of the sets. Okay, so some less arithmetic of this, so we can easily do the problems. So if we have taken A and alpha and beta are the two cardinal numbers. Okay, so we can just have if I'm adding two cardinal number alpha and beta, so the addition of these two cardinal number will be maximum of that. It means if alpha or beta is maximum, or if you are multiplying two cardinal number, then maximum of it. It means alpha or beta. Okay, if I'm just saying what will be the cardinality if I'm just C and LF naught. So it will be C, because C is maximum than LF naught. And then writing increasing order of the cardinal number. Okay, if we are writing 2 to the power C plus LF naught, so definitely it will be 2 to the power C. Okay, so and one thing is, remember 2 to the power LF naught is just equal to C. Remember this. If there somewhere 2 to the power LF naught, that is equals to C. Okay. One thing also I will remember about the counting of the function. So we can also remember some cardinality problems. So if we are just defining a function f from A to B, and here we are going to remember find the counting of the functions on to 1, how many functions will be there if m and n, and cardinality of B is n. Okay. So how many functions will be there if m is greater than n? In this case, there will be no 1 function in the video. 1 function will not exist in this case. Okay, so it means 1 function will be 0. Okay, and if you are just saying bijective functions, so bijective functions will be also 0, because there is no 1 function. But how many onto function in this case? So that will be defined by this formula. This is n to the power m minus nc1 n minus 1 to the power m plus nc2 n minus 2 for m 1 n power 3, and this is your n minus 3 to the power m, and so on. Okay, if here we are just saying m is less than n. Okay, so here no onto functions? No onto function will be there. So no bijective. In this case, no bijective function. Okay. So 1 functions. How many 1 functions will be there? Counting of 1 functions. That will be equal to NCM factorial M. Okay. If M is equals to N, so in this case, onto maps will be equal to factorial N, and 1 will also equal to factorial N, and number of functions, bijective function, number of bijective functions, that will be also equal to factorial N. So remember these things. And one thing and more, how many total functions from A to B? So that will be equal to cardinality of B to power cardinality of A. It means N to power N. This is total number of functions. Okay. So we have a problem on this. They ask in your GATE exam related to the cardinality of a set. So let's talk about that problem. We have a problem. Question is this. Consider the following statement. Please let me know, the audience, you understood the problem, the things. Vasu, are you getting the things?
Yes, sir.
Okay, so let's do this problem together. We have this problem. Okay, so first statement is this. The set of rational numbers and this Q is uncountable. Is it true or false? बताइए.
False.
Okay, it is false. Why? Because cardinality of this Q into Z is
Countable.
just equal to cardinality of Q into cardinality of Z. And we know that Q is the countable, which means cardinality of Q is the LF naught. And this is cardinality of this also LF naught. And when you are multiplying two cardinal numbers, then maximum of this. So here the two are same. So there will be LF naught. And it will be countable. Okay. So this is given uncountable. It means it is a false statement. Okay. Next, the set. This is F, the function. F is a function. Collection of all those functions from a set of natural number to a set 0, 1 is uncountable. Is it true or false?
Yes, true.
Is true. Okay. How many functions will be there? Because we are from n to 0, 1. Okay. So here m is just equal to LF naught and n is just equal to 2. Okay. And we know that when our counting of functions is just equal to n to the power m. Okay, so that will be equal to 2 to the power LF naught, and this is defined. This is proved. It is equal to C. It is defined by the guarantor, that is equals to C, and this is uncountable. Okay, so it means this is true statement. This is true. Another statement is here, for any infinite set, there exists a bijection from the set to one of its proper subset. Yes. What meaning of the proper subset? It means there at least one element is missing of the in a subset. Okay, it is not exactly equal of that. So if from an infinite set, if we remove some finite number, that also remains infinite. Okay, if an uncountable set and we are remove one element from that, and that also remains uncountable. If we are from taking a countable, and that's called countably infinite, and we remove one or two elements, it also remains the countably infinite. It means that for any infinite set, there exists a bijection from the set to its proper subset. Okay, there exists at least one proper subset that we can able to draw bijection. It means if uncountable set, there will be exist a subset of that is uncountable. Okay, so this is a true statement. Okay, next another statement is here. Okay, the set that is a root of P, and P is a prime number, is uncountable. Please let me know. It is true or false. Collection of root of all the prime numbers is uncountable or countable? We know that the prime numbers are 2, 3, 5, 7, 11. And these are prime number, and we can able to list out this A1, A2, A3, A4, and so on. So we can also list out its root. Okay, so it means that this is a countable set. Yeah, you can say countably infinite, denumerable set. So this is a false statement. Okay. Hello, Jyoti.
Yes, sir.
Okay, so meeting is about to over. So uh, it's time to conclude the session. Okay.
Okay, sir.
So I done with this countability and about the directional derivatives today. The student is interested for the next session or not? There only one student. Vasu is there.
Uh, Sir, exactly, I don't know, but we will tell you after some days, in some days.